Hi guys, welcome to the classroom. Today we're going to cover the carbon cycle. So carbon is the element from the periodic table and it has the letter C. Together with oxygen, two of them, it forms CO2 or carbon dioxide. Carbon dioxide can be absorbed into vegetation. Here I drew up a tree and it can make photosynthesis. Photosynthesis is transforming the carbon from carbon dioxide to a molecule called glucose. And glucose is a really important molecule in all kind of living cells. So in order to get on with our cycle, we need the vegetation to die. So the vegetation can die in different ways. It could die under aerobic conditions. It means that there is oxygen present. So if there is oxygen present, here's the dead tree. Bacteria will decompose the tree, and they will make the process called respiration. And respiration will make CO2 and it will re-emit it back to the atmosphere. So this is respiration. So the other circumstances which the organic matter could die was in anaerobic conditions. That means that there is no oxygen present. That means that the organic matter will not be decomposed. It can be stored underground for hundreds of thousands of years. If it gets buried under sediments like clay and sand and more organic matter, then it will be buried under deeper and deeper, then it will go deeper into the ground. And when it goes deeper into the ground, the pressure will rise. And when the pressure rises, so does the temperature. And when pressure and temperature goes up, then we have the forming of fossil fuels. Fossil fuels is of course oil, gas, coal, which we use in our modern combustion engines. So that will be the next step. That will be that the human beings are digging up the fossil fuels and we put them in combustion engines. In the combustion engines, it will be made back into carbon dioxide and then it goes into the atmosphere again. So now we've got the cycle closed. We got the absorption in the photosynthesis and the making of the fossil fuels and back into the atmosphere again through combustion. Okay? The combustion is very equal to the respirational process, which uses oxygen together with organic matter, and then we harvest the energy that was stored inside the organic molecules with carbon in it. So I really want to cover what is carbon neutral fuel. Carbon neutral fuel is if you take the vegetation and you put it into the power plant or the car here for transportation. What happens? Well, what we need to discuss is how long time does each process in this cycle take. So, of course, harvesting the organic matters and burning it takes short time. So does when you burn it and emit CO2, it takes short time as well. How long time does it take to absorb the CO2 in the photosynthesis? It takes like a growth season. It's like, maybe it's months, but at least it's, I know maybe it's a little bit longer than those time spans, but compared to how long time it takes to make fossil fuels, it's really short time. So why is it important to discuss how long time it takes? Because that if you emit CO2 into the atmosphere and the CO2 right away is reabsorbed into organic matter through the photosynthesis, then the concentration in the atmosphere of the CO2, it won't rise, it will stay the same. So this is a really fast cycle and therefore the CO2 in the atmosphere won't rise. What if we compare it to the fossil fuel burning? So burning fossil fuels will of course also make the CO2 rise. But I could argue that, hey, it's also carbon neutral fuel because there's also an absorption and making back into the fossil fuel, so it will be taken out of the atmosphere again and put underground. But here's the point: it takes long time. It takes millions of years, or at least hundreds, thousands of years to make fossil fuels, and it takes a really short time to dig them up and burn them. So this is we could make the example of this being a bank account, and you put money into the bank account really slowly, but you spend the money really, really fast. What happens to the money in the bank account? Well, the money in the bank account won't stay there too long. It will go down, right? So this is the carbon storage that goes down here. Where does it go? Well, of course, the carbon that is being used down here is being put up into the atmosphere. The concentration of the atmospheric carbon or CO2 has gone up from 270 ppm to 400 ppm. Actually, it's plus 400 ppm now. So it's really gone up the past 100 years. So what's up with CO2? Well, it's a greenhouse gas and it causes global warming. So I'm going to give you the real short version of the global warming and the greenhouse effect. So we need the sun, right? And the sun radiates visible light. It's a short wavelength, and it penetrates the atmosphere and it reaches the ground, and it causes the ground to warm up, to get hot. So when the ground gets hot, it will emit heat waves into the atmosphere, and the heat waves want to go back into space. But here's where the greenhouse gas comes into the equation. This could be CO2 or methane or water vapor. So it blocks the heat waves, and the heat waves will then causes the greenhouse gas to heat up. And what happens when it heats up? Well, then this one will start to emit heat waves. So heat waves will then be emitted from the greenhouse gas. Some will go out of space, but some will go back to ground and causes the ground to heat up once again. So this is basically the greenhouse effect. The more greenhouse gases you add into the atmosphere, the more of the heat will be radiated back to the Earth and cause the Earth atmosphere system to heat up. Okay, so that's why we are so interested in the concentration of the CO2. What I also want to discuss is food, because carbon also travels through the food chain. So in order to make food for the population, the global population, a lot of people is eating a lot of meat, so we have to make to feed the livestock, and here the livestock is a cow. So you give the cow some vegetation, grass and corn and soybeans, and the cow will then digest it, and then it will make some energy, and in order to make energy it has to make respiration, and respiration makes CO2. So it inhales oxygen and it exhales CO2. And also in the cow's digestional system, it will produce a lot of methane, cow farts, and the cow's digestional system produces a lot of methane. It's a really big problem. It's a lot of, each day it produces a lot of this. And this is 25 more powerful than CO2 when it comes to the greenhouse effect. So it's really concerning a lot of people, this methane production from the cows. So then the man can eat the meat, or he can eat the cheese, or drink the milk, and then he's also producing energy and making respiration, CO2, and also a little bit of methane. It's not a lot, not compared to the cow at least. Okay, so my point is this: if you give the cow 100 units of food, then it will only produce 1 unit of food for the man or for the population. So here we are actually losing 99 units of food, because the cow has to make a lot of energy. It has a body temperature, and it runs around in the field and stuff like that. So 99% of the energy is lost here. So in the food chain, from the base layer to the next layer, we're losing a lot of energy. So what we could do was just to give the corn and the soya beans and all the vegetables, give it directly to the man. Because if we did that, then we wouldn't have this food chain problem and this loss of energy. Then we would produce 100 times more food for the human population. So that would really solve the food supply problem for the growing population. Okay, so over here I've got the ocean, right? The ocean is really important when it comes to the carbon cycle, because we've got these tiny plants floating around in the entire ocean. These are algae or plankton. And these algae, they will absorb CO2 in the photosynthesis as well and build carbon into their plant cells. Algae don't live very long lives, so they'll soon die. And when they die, some of them will go down, miles down in the deep ocean. And when they reach the deep ocean, well, there's no oxygen down here. So the organic matter will just be stored down here and the carbon will stay down here. If there were oxygen present, then some respiration could occur and we would make some CO2. But here's the thing, the deeper oceans, when the water is down here, it doesn't mix with the surface water for like thousands of years. So the CO2 is kind of hidden away from the atmosphere system. So that's a good thing. So that's a really strong carbon sink we've got over here. So the ocean is really important as well here. So also in the ocean we've got the North Atlantic circulation pump, and this is the Gulf Stream actually. The Gulf Stream goes up north, just south of Greenland, and around the Greenland we'll have a lot of freezing of sea ice. When the sea ice freezes, it won't be able to store the CO2 in the ice, and the CO2 will kind of like being squished out of the ice when it freezes, and then it gets cold, and cold water will sink to the bottom, right? So when it sinks to the bottom, it will have a lot of CO2 in it. So that's like a deep sea pump with a lot of CO2 inside it. I will make a video about the North Atlantic circulation pump as well. There's also salt being squished out of the freezing ice, and that will cause the salt concentration to rise. And salty water is really heavy, so that will make the pump really strong as well. Okay, so yeah, I think this is it actually. It looks really complicated, but I hope you listened during my talk and it makes more sense now. Okay, thanks for listening up, guys. See you later. Bye.